You're dealing with, I need a marker. It's so annoying.
Here, well, one.
Yeah, it's too far away. Since I walk all the way back to your throat.
I'm out of paper. No, I have red.
There's one more back there. So what happens here in the law of science? We have a big S. So dealing with law of science, you have to have the angle and the side opposite. Okay? If you don't, it doesn't work. And what happens is you have two types of given values. You have to know at least one angle in a triangle to be able to use law of science. Okay? You have to know an angle and the side opposite. And there are rules for these things. For example, you're either going to have obtuse or acute. We do not worry about right angles with law of science. It's a waste of time because you've got a standard trigonometry. You don't have to worry about it. So what happens here is you get these basic problems. If you have an obtuse angle, there are only two possibilities. There we go. You're going to have your, think of this as the given angle and its opposite. That's what these values stand for, the big A, little a, and the other side B. So if you're given angle and its side opposite, well, if the given angle is obtuse and the side opposite it is smaller than another side, it can't work because the biggest angle has to be across from the largest side length. If you have an obtuse angle and the side opposite it, if the other side is larger, that means the other angle would have to be larger. Can you have more than one obtuse angle in a triangle? No. That's where this stems from. So what you're looking at here is if A is 135 obtuse, little a is 6, and then all of a sudden the other side length is 10, no es bueno. That's what it is. Okay? You're going to see these A's, B's, and C's and all this other stuff thrown in here. Always think of it as given angle, side opposite. Okay? That's how it works with law of science. It's the given angle, side opposite. That other side length is just any other side length because it can be either one of them. It doesn't matter. The other thing is then if the given angle is obtuse, the side opposite is bigger than the other side, then you're going to be okay. All right? Then you're going to be okay. This is the stuff that we've been working with. You've worked with this and you haven't had to come across the problem yet. What's nice about this, even if you forget this shortcut, this will actually fall into place right away. Okay? It'll fall right, so how you had it yesterday where it said it was go-to error, domain or whatever we're saying?
Yeah.
It does that because, let me show you, I have an example here. If I have, well, this one isn't obtuse, but you get the idea. I'll show you this one in a second. We set this up, you're going to get 4 sine 58 over 2.5. Fortunately, I picked an example. It wasn't obtuse, but when you put this in your calculator, what happens is that this value is larger than 1. It's 1 point something. You can't take a sine, no angle will have a sine value greater than 1. That's why you got that domain there. Okay, that's what happens. So even if you get to the point here where you have an obtuse angle, you forget, and all of a sudden you go through the whole motion, and all of a sudden you try to solve for the other angle, and it says error, double check it. But if you check everything out, right, it just means there's no triangle. It just means that you forgot just remember, given side length, if it's obtuse, or given angle, if it's obtuse, the side opposite has to be bigger than the other side. If it's not, you can't make a triangle. Okay. That's how this one is. The acute ones are the little bit more of the weird ones of how they set up, because you're going to get the possibilities of having multiple triangles. And as we go through these a few times, you're going to start to see that there is a little pattern that occurs. So yesterday, you didn't have to worry about this. Excuse me. You didn't have to worry about these breakouts. You had either you had one triangle if it was a right triangle, and you had one triangle if it was acute and the side opposite was larger than the other side. Okay. Now, if it's acute, these are still, remember, think, give an angle, and its opposite with other side. Okay. What you're doing here is, if the angle is acute and the side opposite it is greater than the other given side, you get that one triangle. That's what we saw a whole bunch of yesterday. All right, that's what you saw a lot of yesterday. I think every problem was like that. The one above that with the right triangle, just knowing that if you have a right triangle and the other angle is acute, you know you can create any right triangle, so it's going to work no matter what. Okay. The weirdness comes in how you check about the no triangle, or what we call the ambiguous case with the two triangle. Okay. So what happens here is that if you're given something like this, where you have your side opposite, and you can take these values and bring the notes over. I realize that since we're getting rid of this book next year, I'm just going to start writing in it, because what's the point?
Right now, is that?
No, well, because they'll probably sell yours to, somewhere. Macau. Here it's nice. Let's see which one. This one?
Yeah, so like in the triangle.
Okay.
Is it 3 A's or 2 A's?
It's just one A, because what happens is, if you have specific angle measures, you get this.
What about the side? Like where the picture line is to?
Oh, this here?
Yeah.
That's a B, sorry. Is that better? Oh. So what happens here is that you can get something like this. So let's say we have angle C is 25 degrees. Little c is 6. The other side is 20. So if I'm looking at this, I have an acute angle, I have its side opposite, and I have the other side. Okay. So what I'm doing here is I'm going to check. Ooh, excuse me. If I check it into these scenarios by just taking the side, this is always going to be the other side, which stands for B, other side. Little a is side opposite. And this is your given angle. If I take 20 sine of 25, what I'm doing is checking to see which of the following occurs. And it's just a short little thing to look at. If I type in 20 sine, what is this, 25? I'm getting 8.45. Now I look at that in relationship to the side opposite. The side opposite is 6. Is 8 and change bigger or smaller or equal to 6?
Bigger.
Bigger. So can I create a triangle with with an angle of 25, side opposite is 6, and another side of 20?
Yeah. No?
Nope.
No.
Okay. Because if you start just thinking about how triangles are created, last year in geometry, I think Sev does this lab. I know that I didn't get a chance to do it last year, but did you guys do the thing on the computer where you tried to create the angle, create the triangles with side-to-side angle?
Yeah.
This is why side-side angle doesn't always work. Sometimes side-side angle works, and it worked when it was hypotenuse leg, but it didn't work with anything else. All right. So if I'm looking at this with a protractor and a straight edge, so if I say 20 centimeters, let's do it this way. Hi, how are you? Good. Here's part D. That's French for two. No, thank you. Pleasantries. You kill them with kindness.
Yeah.
So here's one side length, and then I have an angle of 25 degrees off of this, okay? Okay. And then it's saying that the side opposite this 25-degree angle is 6. Well, it's going to have to, if this is going to have to come up to meet this angle here, it won't reach it. That's what this is showing.
Okay.
That side opposite the 25-degree angle that's given to you, this angle at 25, this being 6, it's not long enough to reach up to the arc or the ray that's created from the angle. It's not enough to close it to create a triangle. That's what that means by no triangle. Does that make a little bit of sense?
Yeah.
You see it when you draw it out like that. That's why side-side angle doesn't always work. Okay? That's why it doesn't work. Now, the same idea goes for when you have this two triangle setup. And I'll show you how it works when you wind up calculating. How do you recognize it when you're doing it with the actual math? If I go to the two triangle scenario, (56, 13, 15).
Where was it, 13, I said? 13 and 14.
So in this case here, I have my given angle. My given angle is 56 degrees. The side opposite is 13 degrees. And the other side length is 14. Did I say 13 degrees? I'm at 13. So if I just go through the idea of what it looks like, well, if I take the opposite side, or not the opposite side, the other side length times the sine of my given angle, I find that value, some decimal equivalent. When I type that in, I get 14 sine 56. I get 11.61. Well, is that smaller than the side opposite? Is that still smaller than the other side given to us? Yeah. So what happens then is that this value of 13, since the ray itself thank you. Trying to be visual and help you guys out. So there's your 13, 56 degrees. There's 14. What happens then is that this value of I put 13 in the wrong spot. It's 56. nuts. Sorry. All right, let me start with crap. So let's see, what do I have? 13. So I need to do the 14 first. 12. So now I got to create a 56-degree angle off of that. And now this value, I'm just going to extend all the way up. What happens then is that this is 56, this is 14. We can take this opposite side of 13, can come across and hit it in two different spots. You come here and it could come over and still hit it here. That's what it's meaning. That 13, that measurement of 13 could reach out and you can get two different angles here and here. That would create it, that's why it looks like it's a little hinge. It would touch in two spots and it'd still be the same value. That's what's created sometimes with this side-to-side angle. Okay. As you go through and we start to do this actual problem where you do come across as ambiguous, it is nothing more than really checking for supplementary angles. Okay. You're checking for supplementary angles to see whether or not they're verifiable to create another angle. Okay. It sounds really weird, and it looks really weird, but yet when we do the problem itself, and we actually walk through it, you should be pleasantly surprised that it's not as scary as it sounds. So I'll show you an example of a two-triangle setup. So the only time you have to really worry about the two triangle setup is if your given angle is acute. Okay? If your given angle is acute, you can go ahead and check it real quick. By doing that, I'm going to take the side that's adjacent times the sine of my given angle, and I'm checking to see, is it smaller than 10, which is still smaller than 11. So right away, if the opposite side is smaller than the other given side, it's also kind of pushing you the idea that, hey, that might be a two triangle setup. Okay? If they're not, if the given side opposite the angle is bigger, you're not worry about it. It could be one of the other ones. But as you start to fill in the blanks, you're going to stumble across it pretty quickly. So doing the math, 11 sine 20. I get 376. So obviously it's smaller, so I know that I'm going to have two triangles. Well, how do we figure this out? We find angle C, like you would normally. So we do the sine of 20 is to 10, as the sine of C is to 11. Does everybody agree that all I have to do is multiply the other side by 11, we're good to go? So I move this over, I get 11 sine 20 divided by 10, gives me my sine value of C. So 11 sine 20, enter, divided by 10, enter. I have 0.37 and change, I have to inverse sine that, and I get 22, if I go to two decimal places, I get 22.1 for C. Now, knowing that there's two possible triangles, that means there's two possible angles that I can come out with then. So here's what we do. We're going to look for supplements. Okay? And the easy way to do that is we need to figure out the possible angle values that are here for B. Okay? So we take the given angle, add to what you got, and we're getting 42.1. We okay with that? That tells me, well, I'm gonna check and see, is there a supplement that'll work to give me angle B still? What's the supplement to 42 and change? 137.9. You okay with that?
Yes.
If I take that 137.9 and I add that back with the 20, isn't there still enough angle left for me the other one? If- Okay. What happens here is that you're going to get two separate possible angles. Okay. You're going to work out. You're going to get the. We have the 22.1. Oops. We know that this one's going to wind up at 137.9 for one of them. But in order to figure out the other triangle, we have to worry about supplements. How these things are bouncing themselves through. Right? Because if you go back to I keep referring back to this unit circle, but I know I haven't really gone in, you haven't gone into it yet. You know how we talked a little bit about ordered pairs the other day?
Yeah.
Your XY values are both positive in the first quadrant. Everybody agree on that? What becomes negative in the second quadrant? X. Now, do you remember when we started talking about the ordered pairs via trigonometry? When I started to show you a little bit about the unit circle, just kind of leading into it? Which one came first? C. C, good boy. Cosine. Cosine winds up being your x values in the unit circle. Therefore, sine winds up being your y values, which tells you that you have sine values that are positive in both first and second quadrants. This goes from 0 to 90 to 180 degrees. So there's a sine, there's an angle here that has the exact same sine value here. Okay. So that first angle that we had found, there's a matching angle. So we found it at 22.1. Remember we found this,
Oh, yeah.
we found this one here?
You said
Oh, I think I said
No.
So if I just come up 22.1 degrees, if I come up from 180 degrees, this angle would be, if I come all the way around, would be its supplement. Do you agree? That's where I'm getting this at, what would I say it was? What's the supplement of 22? 180. Nine, 7, 157.
Yeah, seems right.
So this angle here is at 157.9. These two values are directly across from one another horizontally. Lines that are horizontal share the exact same y coordinates. Remember that? Horizontal lines where y equals some number. Well, I know that the sine of 22.1 equals some decimal. I bet you the sine of 157.9 is the same darn number. Impressive, isn't it? That's why you look at, is there enough degree measures left over inside that triangle to see if I can create this secondary triangle in this second quadrant that the signs match. Does this make any sense at all?
No.
I mean, following a little bit.
Okay.
I did. I just don't know where you're leading. I just don't know.
But where I'm
What?
leaning with is that we all agree that the calculator is going to spit out this 22.1,
Yes.
right?
Yeah.
Okay.
Okay.
So We find that third angle by just subtracting from 180, so this is one possible scenario for B. Now, what I'm getting at is that since this value had something else over here that equaled the same sign value, 157.9, what I'm going to look at it as a second triangle, because we did the math already knowing that there should be two possible triangles here. So what I do is I look at a second triangle, and I call them A prime, B prime, and C prime. What I'm doing is I'm going to transfer the exact same side lengths over and the given angle. So I knew that I started with 20. I knew that this side length was 10, and I knew that this side length was 11. With me so far? Now, what I'm looking at here is this 22.1 was the first angle that we found. By looking at it this way, I found its supplement. You agree? I just took 180, subtracted it. Now, coming back to this triangle, if I put 157.9 here, is there enough degrees left over for angle B?
Yeah.
Therefore, I can have a second triangle by doing that. All I'm doing here is once I realize that the possibility arises that I can have that secondary triangle, I just check the supplement to see if there's enough degrees to make another triangle. Basically, by looking at the supplement, it's going to alleviate all this crap. Because all you're doing is checking to see, I find this first angle, 22.1. What's its supplement? 157 and change. 157 and change plus 20. Is there enough there to make left over to 180? Yes or no? If yes, two triangles. If no, no two triangles.
Oh, okay.
All right?
So we don't have to write out the second triangle? Or
Well,
do we?
yes, because if there are two triangles, then you can just find the other angles and the other side. Because basically what you're doing is that you're going to find the other possible angle for B and the other possible side length for B. That's all you're doing. Because what happens when you have that acute angle and those sides start falling into place, even if you forget all that stuff on that chart, if you are given side-side angle, all you have to worry about is when you get that second angle, check its supplement versus the given angle and see if there's another degree left over for you to use. If there is, you've got two triangles. If there isn't, you don't. Let me show you another one.
Okay.
Okay. 160.
Okay.
160.
That's a big triangle.
So what I'm going to do here is I'm not even going to verify via that chart. I'm going to draw my picture and then go off supplements. A, B, C. It's easy as 1, 2, 3. Side angle, do you agree?
Uh-huh.
Which other angle am I going to solve for first?
C.
C. Good boy. That gets old, I guess. Obviously, at this point, all I have to do is take 60 times the sine of all that other stuff and go from there. So, 160 sine 70, enter, divided by 155, enter. Second sign of my answer, and I'm getting $75.93.
Yep.
Okay with that?
Yep.
Automatically, I'm going to check to see if there is a C prime via that supplement. So I take 180, subtract 75, 93, I get 104.07. What's 104.07 plus 70?
Not 180.
Not 180, so is there enough for two triangles?
Yeah.
That's all I'm doing.
That's
Oh.
what the
Okay.
That was
That's
so much.
all I'm doing.
And then
Okay.
that's it.
Okay.
The first
Or do you have to
example was
find-
so confusing.
The circle
That-
triangle.
I
Circle
don't think
thing
we need to know anything
threw me
about
off.
that.
Yeah.
You don't want me to show you that way?
That was
Because
easy.
this is the reason why it does occur.
Okay.
Because you're just, bless you, you're just flipping quadrants, okay? Sign values don't change because they're horizontal from one another. Each angle in the first quadrant, which your calculator is finding for you, calculator is only going to find sign values between, well, actually, between first and fourth quadrant, because you can get negatives, but we'll get to that later. So that tells me that I have two possible triangles because I know that this works with this. So when this occurs, well, you just have to solve it twice. You just fill out another triangle. So you have 75, 93, which means angle B then would be 145, 93, so it's going to end in the 704.3. Is it 3407?
Sounds right.
Yeah.
Yeah.
Sweet!
So the supplement is 104.
The supplement, yes, I'm checking the supplement of this to see if there enough angle left over. So I know that I can have the A prime, which was my original, at 70, which gives me the B prime. 593. So you have two possible angles for C, which means you'd have two possible angles for B, which means you'd have two possible sides for B. You just do the law of sines 2 more times.
Okay.
All you have to do is check, after you get that second angle, does it have a supplement that can create a second triangle? That's all you're doing. Okay? That's all you really have to do. I know, sorry, you have to. Visual, draw pictures, and go. Should we do another one?
So then you have to draw another triangle for the supplement and like all that.
Yeah, it's a little bit easier because, well, I mean, I still have to find side B here, so I'm just gonna do, sine of 70 is 150, is to 155 as the sine of 3407 is to little b. So I still have to sign up little b here. I found b by just adding up to 180, so I'll just use the sine of 70 is to 155 as the sine of 5.93 is to other side b, other little b prime. So I'm creating two possible triangles.
So you always use the original, like the given,
Yes. Mhm.
even for supplement.
Yes, because your givens here for the prime one is still 70, 155, and 160. And then you're just filling in the blanks. Well, the other possible angle for C was 104.07, and then this one would be 5.93. So as you go through it, you're still going to get the possibles of the largest angle is going to have the largest side, smallest angle, smallest side, medium angle, medium side, and so on. Okay. But the idea here is once you find that secondary angle, you just bounce it around and see if it works. Now, do you have to worry about this if you're given side angle side? No. Well, actually, side angle side would be law cosines. Well, no, we can do law of sines still, but it's going to be that side angle scenario that this has to really worry about. Okay. Angle side angle, you don't need to worry because you're going to be given your two angles, so you know that what the third one has to be, so you don't have to worry about it. Okay. It's usually the side angle. That's why we call it the ambiguous case. Whichever one that okay. A is 140, little a is 5, and little c is 7. What do you do first?
You gotta find the angle of C.
All right.
First you gotta draw a picture.
What's that? Yeah, go for it. Okay, you wrote that. At home. Hey guys, you should have just not realized. Well, it's obtuse, but look at the side lengths. You should not even have to do any work here. It's not a
It's not a
triangle.
triangle.
Oh my word.
Yeah, I was getting that. I would have figured out eventually.
I know, but you guys remember, use what you already know.
But I didn't know that.
Well, yes, you did. You just
I
forgot it.
didn't think about it.
Exactly. If you forget it,
You have
no, now you
it's-
know again.
This is going to be the biggest angle in the triangle,
Maybe respectful.
which means this side has to be the biggest side. No, 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 no.
I think Seth was told last
Yeah,
year. Each of
yes, that's what we do. Add to your stuff, 29 to 33.
Dang, I wrote on better.
So this is still page 804.
804.
Yeah. Tomorrow we'll go into law of cosines. It doesn't take very long to show that. Usually when you deal with law of cosines, you just use it once and then you fall right to a law of sines problem, and then you just do the same thing here. Now, I have been known to create law of cosines problems that do generate multiple triangles.
More than two?
What's that?
More than two?
Well, no, actually two triangles. So I have been known to create problems with law of cosines that will generate two triangles out of it. So the idea of always after you do law of cosines, you're finding the secondary angle, and then you can dump around and see if you can find that supplement and go from there. Sir?
They have that TED Talk thing tomorrow in the forum room. Would tomorrow be a day that I shouldn't miss? Or like,
Do you remember law of cosines?
a little bit?
Watch the video. I mean, you guys are responsible for it, so I mean, I'll have the video up. It'll be law of cosines, and then, like I said, I have been known to throw in an ambiguous case, so just be careful.
Alright.